Hi everyone, welcome to our channel. This video is a continuation of our previous physics lesson. Let's now get straight into the question. The question says, the number of turns of the coil of a moving coil galvanometer is increased in order to increase current sensitivity by 50%. The percentage change in voltage sensitivity of the galvanometer will be. Here are the options. So what are they asking us to find is voltage sensitivity of the galvanometer will be. What if we have to increase the current sensitivity by 50%? So if we have to increase the current sensitivity by 50%, then the number of turns of the coil will also be increased, right? And that's what they have also given us. So in order to solve this kind of questions, you'll have to know two basic formulas. The first one is current sensitivity formula, which is NAB by K, where N is the number of turns of coil, A is area of coil, B is magnetic field, K is restoring torque per unit deflection. Okay, the next formula we'll have to know is voltage sensitivity, which is equal to SI, current sensitivity, divided by resistance R. Okay, we'll now start solving the question. Okay, they have given us that there will be, in order to increase the current sensitivity by 50%, so we are now gonna increase the current sensitivity to 50%, right? So from this formula I can say that I is directly proportional to N, that is SI is directly proportional to N, SI directly proportional to A, SI directly proportional to B, and SI inversely proportional to K. Okay, if there is gonna be an increase in the current sensitivity by 50%, then how can I write SI new? I can write this SI new as SI original, that is what value the current sensitivity previously was, plus 50 divided by 100, that is the new current sensitivity. This one is the new current sensitivity, the changed one. So the total new current sensitivity will be SI plus 50 by 100 SI. So that will be 1.5 SI. This is the new current sensitivity. Okay, from the formula we have found out the relationship between SI and N, right? If there is gonna be an increase of 1.5 SI current sensitivity, then there will also be an increase by 1.5 times the number of turns of the coil from this relation. Hence I can write this correct. Also, R is directly proportional to N. How is R directly proportional to N? This is because from the formula R is equal to rho L by A. I can say that R is directly proportional to L, right? So if R is directly proportional to L, we know that N is directly proportional to L. How? Because as the number of turns of coil increases, it is obvious that length also increases, length of the coil also increases, and hence this relation. So I can, from both of these relations, I can say that R is directly proportional to N. Correct. So if that's the case, then if N is gonna be increased by 1.5 times, then it is directly proportional to 1.5 times R. Okay. So what are they now asking us to find out? They are asking us to find out the percentage change in voltage sensitivity. So the only formula that we have for voltage sensitivity is this one. SV is equal to SI by R. So writing that here, SV new, because they are asking us to find out the change, right? So SV new is equal to SI new divided by R new. The change that we saw for SI new is 1.5 SI, and the change we saw for R new is where is it? 1 minute. Here 1.5 times R, and that's the new R. 1.5 and 1.5 gets cancelled, and what we have over here is SI by R, and we know that SI by R is nothing but SV, current sensitivity. So SV new is equal to SV. Since the new and the old one are both equal, hence I can say that there is no change in voltage sensitivity, therefore 0% change. Hence the right answer for this question is option D, 0%. Moving on. The next question we have right over here is also a similar one to the previous question that we have solved just now. The current sensitivity of moving coil galvanometer is increased by 25%. This increase is achieved only by changing in the number of turns of coils and area of cross section of the wire while keeping the resistance of galvanometer constant. Remember this one. The percentage change in the voltage sensitivity will be, again they have asked for us to find out the change in the voltage sensitivity. Okay, let's solve the question. We know the basic two formulas, the voltage sensitivity and the current sensitivity. Using those two formulas only we are gonna solve this question as well. Okay, so what have they given to us? They have given us that there is an increase of 25% in the current sensitivity. So current sensitivity new is equal to SI plus 25 by 100 into SI. Why 25 by 100? Because they have increased the current sensitivity of moving coil galvanometer by 25%. Okay, so this SI is nothing but the value that was previously shown in the galvanometer as the current sensitivity. So this one is the old value, okay, and this is the new value. That is the change that we saw, that we right now see in the galvanometer. So the current sensitivity new will be SI plus 25 by 100 into SI, which is equal to 1.25 current sensitivity. Okay, so we have solved up to this line, right? The next line says this increase is achieved only by changing in the number of turns of the coils and area of cross section of the wire while keeping the resistance of the galvanometer constant. So here we are achieving the change in 25 a change of 25% increase in the coil, that is the moving coil galvanometer, by only changing the number of turns and area of cross section while keeping the resistance constant. So the only constraint that we have over here is R is constant, whereas number of turns of coil and area of coil are gonna be varying. That means it is also changing. Okay, so we know that SV is equal to SI divided by R, or I can write according to this question as SV new, because we have been asked to find out the percentage change in the voltage sensitivity. So SV new is equal to SI new divided by R new. No, it's not R new, it's just R. Okay, I just tricked you. Why is it just R? Because they have given us in the question while keeping the resistance of the galvanometer constant. Resistance is constant, so R is gonna be as it is. Okay, SI new, we know that it is 1.25 SI divided by R. R comes as it is. SI divided by R, we know that it is SV, therefore SV new is equal to 1.25 times SV. Okay, so the change in the current, the voltage sensitivity is 25%. How am I saying that it is 25%? This is because 1.25 minus 1 into SV is equal to 0.25 times SV. So that's 25%, right? Why 1.25 minus 1? Why am I subtracting it by 1? It is only because the initial value was as it is. It was just 1 SI, right? So it is going to be 1.25 minus 1 times of SV is equal to 0.25 SV. Multiplying that by 100 in order to change that to percentage, we get 25% as the change in the current, in the voltage sensitivity. So the answer for this one is option A, plus 25%. That was so easy, right? So all you have to remember is that these two formulas which I have given you over here, this one and this one, remember these formula, and also the questions that I have solved today are really very easy. Okay, but there are some places like they have given resistance of the galvanometer to be constant. Okay, if you did not see this constraint, then you might have ended up with the same answer as 0 as we saw it in the previous question. Okay, so always read the question twice, understand it, and then solve it quickly. Okay, let me move on to a bonus question, which is really very easy. If you just know the formula, you'll definitely complete it. Okay, now let's move on to the next question. The number density of free electrons in copper is nearly this. A copper wire has its area of cross section to be this one and is carrying a current of 3.2 amperes. The drift speed of the electrons is. Okay, so this question is simple. If you just know this formula, I is equal to NEAVD, where N is the number density of charge carriers. So this typically is the number of free electrons per unit volume in the material. Okay, E is 1.6 into 10 to the power minus 19 coulomb. A is the area of the cross section. Okay, so area Vd is the drift velocity or the drift speed. Okay, you know that it is current. So they have given the question, the number density n is equal to 8 into 10 to the power 28. The number density of free electrons in the copper wire in the copper is nearly this one. And electron, this one, E, is 1.6 into 10 to the power minus 19. This is the charge of a single charge carrier. Okay, this one. A is the area of cross section, and they have given that to be 2 into 10 to the power minus 6. They are asking us to find out the drift velocity, that is Vd, and they have also given the current value to be 3.2 amperes and is carrying a current of 3.2 amperes. I is equal to 3.2 amperes. Vd is the only thing that we'll have to find out. So 3.2, I is equal to 3.2, which they've given over here. 3.2 is equal to number density of charge carriers is 8 into 10 to the power 28. E is 1.6 into 10 to the power minus 19. A is 2 into 10 to the power minus 16 into drift velocity that we have to find out. Rearranging, we get Vd is equal to 3.2 divided by 8 into 10 to the power 28 into 1.6 into 10 to the power minus 19 into 2 into 10 to the power minus 6. Solving this, we get 125 into 10 to the power minus 6 meters per second. So this is the drift velocity, and the answer for this one is 125 into 10 to the power minus 6. Okay, they have given us 10 to the power minus 6 here already, so I really shouldn't have written over here. So 125. I hope everything was clear to you all. Stay tuned for more exciting physics videos coming up soon.